Designing the power supplies for your transceivers can be the most difficult aspect of your power design. These supplies typically require extremely tight tolerances as well as very low noise specifications. The reason for this is the analog nature of the interfaces that you're powering. Any type of noise, any type of regulation error that's introduced on the power supply is going to be translated onto your outputs. This can result in limiting your maximum data rate, bit errors, and things like that. With that in mind, Avnet has worked with several of our power manufacturing partners to try to develop a series of reference designs to help get you started on your transceiver architecture design. Now, as is the case with so many things on an FPGA, it's not a one-size-fits-all type of solution. You have to do a little upfront work to figure out exactly what your specific power needs are going to be. In this video, we're going to go through some of the steps in defining your power architecture requirements and then where you can get information to help you design to those specifications. So when you open up XP, you're going to see this window in front of you. You've got your device settings, the environment settings, all the things that we've gone through in previous videos and explanations of how this tool operates. The first thing you're going to want to do when you start looking at your transceivers is select the proper device that you're using. So for this example, let's go with a Xilinx 7000 family. We'll go with a 7045 device, and you'll see that this tab right here labeled GTX, this will change depending on the type of transceivers available, whether it's GTX, GTH, GTP. This will reflect the type of transceivers that are available in the device that you've selected. If you click on this tab, you can go and you can enter your transceivers manually here by selecting all the parameters. I'm not familiar enough with the different transceiver interfaces to be able to do this manually, so what I'm going to do is go to the Summary tab again and click on this Manage IP button. The Manage IP button will bring up this interface where there's different things that you can select. If we come here to select Transceiver Interface and Create, it will bring up this window where you can actually go in and select the protocol that you want to use for your interface. For this example, let's do DisplayPort. It will let you select the data rate. Let's try 5.4, and as well as the number of channels. Also the operation mode, transmitter, receiver or transceiver, the data path, number of bits, power mode, data mode, clock source, as well as the voltage swing. So all of these things are configurable inside this window. If we click Create here, that creates the transceiver interface, and you will see that the power consumption for the MGT rails has increased. Another thing you'll note is that there's actually power consumption on the logic as well. This is an important thing to remember when you start designing your transceivers, is that in addition to needing to provide these additional analog power supplies for the transceivers themselves, adding these transceivers also increases the loading on the logic supplies. So again, just an important thing to note when you're doing your full-blown power analysis. So if you come over here to the GTX tab, you'll see that we entered 4 channels, which is 50% utilization in this particular device. This current generation of XPE tool doesn't give you a counter on how many transceiver channels are available based on the device you've selected. Chances are you probably know this, and they may add that in later revisions, but right now it's not in there, so you just need to keep track of the number of channels available and how many you've used. So since we still have 4 channels available, let's go in here. You'll see Manage IP. This will show you the transceiver that you've already created. You can come in here, you can delete it, or import another one, or export this to another file. Let's create another transceiver interface. This time let's do Ethernet interface, 2.5 gigabits per second, and we've got 4 channels left, so I'm going to do 4 channels here. When you click Create, that will add that transceiver into your power analysis, and you'll see that the power for the core voltage rails has increased, as well as the power has increased on the MGT supplies. We come over to the GTX tab, you'll see that the utilization is now at 100%, and you can see your two transceiver interfaces selected here. One thing that is also, I don't want to say a limitation, but isn't immediately obvious to you, is that when you come over here and you click on the Manage IP, you'll see the two transceiver interfaces are now active. When you click on Create IP and you create a transceiver interface, we don't have any channels available anymore. So I'm just going to select something arbitrarily, one channel, and click Create. You'll see that the number of channels specified exceeds the 0 available. So this is a warning telling you that you've already used all of the available channels of your transceiver interface. One thing that confused me when I first used this tool, and I wanted to make you aware of, is that when you create these, when you go here and you click Create and it creates one of these interfaces, it doesn't close this window automatically. What do I mean by that here? I'm going to delete this one and do that again so I can show you what I mean. So I go in here and I want to create a transceiver interface. I'm going to create the same type that I just did, but if you watch, when I click Create, okay, it created that interface, but obviously it didn't close this dialog window. It didn't bring me back to another screen. So the first time I was doing this, I didn't think it actually had created anything. You have to click Close here, go back to Manage IP, and you'll see that it did actually create it, even though it didn't close that window. So just something to keep in mind when you're using this tool, is that even though it doesn't change the window when you click Create, it does actually create the interface that you were designing to. So again, with that, you will now see the transceiver rail voltages and currents that you need to design, as well as you'll see the increased loading on the core voltage supplies that need to be accounted for when you're designing your transceiver interfaces. So hopefully this little tutorial helps you get an idea on how you can specify the transceiver requirements that you need, as well as define the power requirements based on those transceivers. Using this information, you can then use these voltages and currents to use the reference designs that we've created and select the proper voltage and current requirements for your specific application, or use these figures to go off and create your own. I hope you found this little tutorial helpful.